Good afternoon, students. Myself, Dr. Sandeep Gupta. I am assistant professor in Ajay Kumar Garg Engineering College. Department is Applied Science and Humanity Department. I am taking chemistry lectures here. So, today my topic is battery. When two or more electrochemical cells are electrically interconnected and each of which containing two electrodes and an electrolyte, it is called battery. Or in a simple word, you can say it's a combination of cell. It's a combination of cells. Okay. So these cells are arranged in a series. And what is the cell? This cell is basically one cell contain electrodes and these electrodes may be anode and cathode. Here the symbol of anode is written as negative terminal and the cathode symbol is represented as positive terminal. So this cell is made by electrodes and these electrodes are submerged into electrolytes. Okay. So this is basically cell, which is a combination of electrodes and electrolytes. So in another word, we can say battery is a combination of electrodes and electrolyte which are arranged in a series and is capable to produce electricity. Or in another word, I can say, if I will discuss the cell, so this cell could be two type. You all know, I think, this cell will be converted into two part. One is electrochemical cell, and another one is electrolytic cell. Here, one thing I would like to add, that the electrochemical cell, the conversion of chemical energy occurs into electrical energy. So those cells in which chemical energy, some chemical reaction is going on, and by the chemical reaction, what is the output is the electrical energy. And here the Gibbs energy will become negative. As you all know that as we can utilize the battery, the energy is going to reduce as per our usage. And in electrolytic cell, the electrical energy is converted into chemical energy. Means from outside you are giving the energy and this energy is converted into chemical energy. Okay. And the Gibbs energy will become positive. As you can see, when your mobile get discharged, then you can see you will just plug it in switch and then switch on the electricity. Then what happens? The electricity go inside it and your battery is going to be charged. Means Gibbs energy is going to be in a positive scale. So this is also one different classification of cell. Okay. And the cell is basically the combination of electrodes and electrolyte. In both electrochemical and electrolytic cell, we have electrodes and electrolytes. So I am going to discuss another thing, that this battery is different in design, is different in structures as per the uses. Means everyday uses battery is also used. Okay, and no battery design is perfect for every application. Means if you are using this microphone, then this battery is quite different. If you are using your cell phone, then battery is different. So on the basis of uses, you can say the battery, this battery can be classified into two parts. One is primary cell and another is secondary cell or secondary battery. So primary batteries are those batteries which cannot be recharged, which is use and throw type of battery. This primary battery is further divided into two parts. One is, you can say, Daniell cell or Leclanché cell, which is, you can say, dry cells. Okay, and another one is basically, another dry cell is called button cell. Okay, while the secondary battery which can be recharged. So this can be on the basis of structure, on the basis of uses, it can be lead acid battery and cadmium battery, nickel battery and lithium ion battery. So this is also one of the classification of the battery, primary, secondary, and in dry cell we study the pencil cell or Daniell cell, or you can say Leclanché cell, and the button cells. So the button cells is used in microphones or in, you can say, headphone, earphone. Lead acid battery is used in inverter batteries. Cadmium ion batteries, nickel ion batteries are used in specific, you can say, gadgets, and lithium ion batteries are used in mobile phone. So we'll move to the next slide. So this is another type of the battery. I am going to discuss one classification, which is primary battery and secondary battery. So primary batteries are those batteries which are non-rechargeable and are meant for only single use and meant to be discarded after this use. Once you use, just throw it. It cannot be reused again. Means somewhere it also associated with the pollution. Okay. Also lead storage battery also creates pollution. Okay. So primary batteries are non-rechargeable and are less expensive. The cost is very less because it produces only 0.25 ampere current. Okay. So its cost is also very less and are often used in ordinary gadgets like torchlights, watches, toys, and some other specific objects. And commercially, many kind of primary batteries are available, but we will discuss only Leclanché cell here, which is a part of syllabus. So the instrumental setup is in lab is quite this, where this zinc electrode is placed in one electrolyte, which is ammonium chloride, and this complete zinc and ammonium chloride is interacted with this porous vessel or porous, you can say again, electrode having manganese oxide, and this is MnO2. Okay, and this is basically graphite rod or carbon electrode. This is graphite electrode or carbon electrode. Okay? So this is the lab setup, and the compact form of this lab setup is represented here. So in this diagram you can see the outer shell is made by zinc, okay, and this zinc act as anode here. We will discuss later why we are saying anode. And this zinc is basically quite segregated with this thing, and this is basically one more electrode, which is carbon electrode or graphite electrode. Okay, this graphite electrode is surrounded by another powdered substance, which is a combination of manganese oxide and carbon black or charcoal. Carbon black or charcoal. These two electrodes are submerged in ammonium chloride solution, which is saturated solution of ammonium chloride. So ultimately what is going on, I am going to discuss. So from this side, the zinc container which act as anode, it liberates electron by this reaction. This zinc is converted into Zn2 plus and 2 electrons, and these 2 electrons are moving to the carbon electrodes, and by this way, in an opposite direction, the current tends to start, and this bulb will enlighten. While on cathode, what is going on? This MnO2 is converted into MnOHO. So here you can see the change in oxidation number. Here the oxidation of this oxygen is -2 into 2. -2 is basically the charge of oxygen multiplied by 2 atoms. So the total oxidation state of manganese is +4, because total charge here is -4. So the oxidation state of manganese is +4. As here the oxidation state of the zinc is 0. Okay. When the 0 is converted into 2, it means oxidation state is going to increase, and this increase is named as oxidation process, and this oxidation occurs on anode side. Okay, so this is basically anode of this Laclance cell, while in MnO2 +4 valency is going to be substituted by, on the hydroxide charge is -1, because you know oxygen have -2 charge and hydrogen has +1 charge. Net charge is -1. So hydroxide is -1 charge, and the oxygen atom remaining here having -2 charge again. So total charge on this species is -3. So the oxidation state of the manganese is +3. So +4 is going to reduce to +3. It means the reduction is going on, and the reduction occurs on cathode. Okay, but one thing that I would like to add, that here no hydrogen atom is present, but the hydrogen atom is here present. So from where this hydrogen atoms comes? So this hydrogen atom comes from this ammonium ion or ammonium chloride ion, which get dissociated into ammonium ion and chloride ion. So from there we will get ammonium ion and 1 electron. Okay, So ultimately I am writing again this complete equation. What is this? This is MnO2 plus ammonium ion plus 1 electron. It is forming MnO OH, you can say, plus ammonia gas. Okay, if here is 2 electron, here is 1 electron, so what I will do in net cell reaction, I will multiply this with 1 and I will multiply it with 2. So what I will get? I will get 2 MnO2 plus 2 ammonium ion plus 2 electron, which can be cancelled out later on, and it will form MnOH or O plus, it is also 2 and 2 NH3 gas. I can write this species as Mn2O3. Here I have 2 oxygen, 2 atom of oxygen, 2 oxygen and 2 hydrogen. So I have total 4 oxygen and 2 hydrogen. Okay. So I am utilizing here 3 oxygen atom. Now I have only 1 oxygen atom remaining and 2 hydrogen atoms left again. So here I can write down this species as Mn2O3 plus 2H2O. Okay, or you can say H2O. ठीक है, 2H2O plus 2 ammonia gas. So this ammonia gas creates problem. This ammonia gas creates problem. Let me check whether this equation is balanced or not. We have 2 4 ja 8 hydrogen, we have 2 3 ja 6 and it is only 2 hydrogen. Okay, so that is also 8. We have 3 and 4 oxygen atom and here we have 4 oxygen atom, rest is all right. So this reaction is now balanced. So what I am trying to say, that this ammonia is produced, and if the ammonia continuously produces, what happens? It exerts a pressure on the cell, and if it is not rectified, then this cell will be rupture or blast. So it can be converted into different state. We will convert it into aqueous state. Okay. So what happens? This ammonia get converted into aqueous state by interacting with zinc 2 plus ion. It forms a ligand, and this ligand will be this is ligand compound, okay, and occurs in form of aqueous form. So this gaseous form get converted into aqueous form. So by this way it cannot create an additional pressure on the cell, and by this way the cell will not rupture, it will not burst. It can only leak, and after leaking you can just get an idea that the cell is now useless, and just throw it and replace with new. So this is all about the Leclanché cell. So you can see what I have written here. A Leclanché cell consists of a carbon electrode packed in a porous pot containing manganese dioxide charcoal powder, and the porous pot is immersed into a saturated solution of electrolyte contained in an outer glass vessel. A zinc rod is immersed into electrolyte solution. This is all about this lab setup. Okay, and the reactions I have already explained how the zinc is converted into zinc ion that produces 2 electrons. These 2 electrons are received by manganese oxide and manganese dioxide. This interact with ammonium ion by receiving electron. It converted into Mn2O3, ammonia and water, and the cell continuously performs electricity for a limited time period, and after that you just discard it and throw it. So this is what I have written. This is the short reaction. So you can just see the complete reaction from the previous slide, and it will be helpful for you. So the EMF produced by this way is about 1.5 volt. So the cell is, this Leclanche cell is of 1.5 volt that supplies 0.25 ampere current. Okay, so it can be helpful to use low, you can say low demand gadgets, low energy demand gadgets, but not for very high energy demand gadgets. So I am going to discuss another one, which is the secondary battery. So I already told you the secondary batteries are rechargeable battery, means they can be used for a multi-cycle use. After the use, the electrochemical reactions could be reversed by external application of the voltage. You just, once the battery get drained, you just put it in plug, switch on the light electricity go inside the cell and recharge the cell. The cell is again used many times. So the cycle is reversed till the capacity fades or lost due to leakage or internal short circuit. So this cell, which is converted from electrochemical to electrolytic and electrolyte to electrochemical, this cycle is reversed many times, okay, till it will not fade, it cannot be leakaged, no internal short circuit occurs. Hence, it will reuse again and again. These cycles are rechargeable and reusable. A combination of all reversible electrochemical cells gives secondary batteries. Many kind of secondary batteries are present in market. I have already classified. This is lithium ion batteries, this is cadmium ion batteries, nickel batteries and lead acid battery. But the concern of the syllabus is lead acid batteries. So I am going to discuss lead acid battery. So this lead acid battery is basically a combination of two electrode, anode and cathode, submerged in electrolyte. So here anode is basically, this is the anode part, this blue color representation is anodic part, and this is made by spongy lead. This is made by spongy lead. Okay, and the cream part representation is basically cathode, and this is anode, and this is H2SO4, which is 38% sulfuric acid solution, and the volume water ratio of acid and water is 3:1. Okay, so what is going on with this battery? We will discuss, we will see all the reactions in detail. So first of all, at anode, so the anode is made by Pb. This Pb is converted into Pb2 plus ion by releasing 2 electrons. Okay, so the change in oxidation state is 0 to 2, means the oxidation state is going to be increased. Hence this is anode and the oxidation is going on. This Pb is converted into Pb plus 2. This Pb plus 2, this plumbous ion is interacting with sulfate ions of H2SO4. You all know H2SO4, we have hydrogen 2 atoms and sulfate ion 1 atom. Okay, but in 2H2SO4 we have 4 hydrogen atoms and 2 sulfate atoms. One sulfate atom, ion is interacting with this lead ion and it is forming PbSO4, lead sulfate precipitates, and ultimately the complete cell reaction will become, this Pb to Pb cancel out, and now Pb plus SO4, it is converted into PbSO4 plus 2 electron. So this is basically complete cell reaction which is going on anode, and the E cell potential difference of this is minus 0.356 volt. So I have written here that this Pb is converted into Pb plus PbSO4, it is forming PbSO4 plus 2 electron. So this is the complete cell reaction, while the half cell reaction is written by this way. Okay. Now again I am discussing the cathodic reaction. So what is going on cathode? So cathode is made by PbO2. This PbO2 is converted into Pb plus 2 ion. Okay. So total change in oxidation state is -4, means this is 4, 4 to 2, means the reduction is going on. So this reaction is going on cathode. Okay. So this PbO2 interacts with 4H ion, means we have 2H2SO4, it can be written as 4H ion and 2 sulfate ions. So it is interacting with 4H ion plus 2 electrons. Okay. Then the net product will be Pb plus 2H2O. This Pb plus ion again interacting with one more sulfate ion. So it is interacting with one more sulfate ion and it forms PbSO4. The net cell reaction will be, this will be cancelled out, and this is PbO2 plus sulfate ions plus 4H ion plus 2 electrons, and it will form PbSO4 plus 2H2O. This is the reaction which is going on cathode. And what reaction is going on anode? This is Pb plus sulfate ion minus minus, it is forming PbSO4 plus 2 electron. So complete cell reaction is 2 electron to 2 electron cancel out, and here you can see lead plus lead oxide plus 2 sulfate ions plus 4H ion, it will form 2 PbSO4 plus 2H2O. I can write down it as 2H2SO4 also. So when the battery is in operation mode, means battery is going to be discharged, means it is behaving just like electrochemical cell. So when battery is discharging, or behaving just like electrochemical cell, where chemical energy is converted into electrical energy, and where the electrical energy, we are getting the electrical energy by these two electrons. Okay. So, during discharging, the reaction will become Pb plus PbO2 plus 2SO4 plus 4 H ion forms 2 PbSO4 plus 2 H2O, or it can be written as PbS solid, PbO2 solid, 2H2SO4. This will be combined and form 2H2SO4. 2H2SO4 aqueous, it will form 2 PbSO4 solid and water. So, by this way, the discharging reaction is going on. Once the battery will discharge, electrolytic cell, now battery have been discharged and we want to charge it again. So, what we will do? We will just charge it by the external source of electric current. Means now the battery will behave just like electrolytic cell. So, when the battery, suppose this is the negative terminal of the battery, this is the positive terminal of the battery, means this is Pb and this is PbO2. It will be, interact with two terminals of the battery, positive side of the battery and negative side of the battery. Then this will behave just like electrolytic cell, and this is basically now the charging reaction. Means now the battery have been discharged and I am going to charge it again, means charging by connecting it with the external source of the current. So, now the reactions will be completely different. So, what will be the reactions now? Means this PbSO4 plus 2 electrons, it is forming lead and sulfate ion. This PbSO4 plus 2 electron, it will form Pb plus sulfate ion, and PbSO4 plus 2H2O, it will form PbO2 sulfate ion, 4H ion and 2 electron. So, net cell reaction will become 2 PbSO4 react with 2 moles of water, that produce the product lead solid, lead oxide solid, 2H2SO4 aqueous. Means those, when we are interchanging the cell from electrochemical to electrolytic cell, the anode of electrochemical cell will behave just like cathode, and cathode of electrochemical cell will behave just like anode. So, that is why the reaction will be reversed. Okay. So, when the cell behaving just like electrochemical cell, just find the net cell EMF. So, you all know that E naught cell, in case of when the battery is discharging. So, this is E naught cell will be E cathode minus E anode, and the cathode EMF is written here. In case of electrochemical cell, it is basically 1.685. This is 1.685 minus 0.356, and its value will become 2.041 volt. So, I can conclude it by saying that each cell of the battery produces near about 2 volt current, or 2 voltage difference occurs in between anode and cathode. So for 12 volt battery, we need 6 cell, such type of cell, where Pb, PbO2, 2SO4, 4H ion, 2 PbSO4 plus 2 H2O is going on. We need 6 type of the cells where the same reaction is going on, and total EMF of the cell is 12 volt. Okay. While in the electro, once the battery will discharge, you can just reverse all the reactions by saying that this is now the battery is going to be charged and behaving just like electrolytic cell. So the reactions will be quite inversed. Okay. So what are the various problems and various advantage of the cell, you can say? So there are very few problems with the design if the cell voltage exceeds 2.39 volt. The water breaks down into hydrogen and oxygen, and this hydrogen and oxygen again exert an additional pressure on the battery. Okay, and there is a chance to explode the battery. Hence, is outer part of the battery is made by, you can say, polypropylene, bakelite or polystyrene. So basically we use bakelite just to make this outer cover. Okay, and this outer cover exert an additional pressure on hydrogen and oxygen gas and convert again into water. So another problem that arises from this system is the acidic fumes. So these acidic fumes corrode the nearby surroundings metallic objects and makes unethical, or some kind of smell comes from the battery size. Okay, so just to remove the acidic fumes, we have to keep the battery in a ventilated area. Another part is the problem are mostly solved by sealed. The above problem, okay, have been solved by the sealing of the battery. This sealing is reality is only valve regulated and allowing hydrogen and oxygen recombination using catalytic recombination. They convert these gases back into water, achieving about 85% efficiency at the best. Means you just pressurize hydrogen and oxygen and convert H2 and O2 into again H2O. Again we will not fill again and again the by the water this battery. Another problem that is faced by the battery in the hilly areas, it is when the temperature decreases 1 degree centigrade. When the temperature decreases 1 degree centigrade, it reduces the EMF 1.45 into 10 to the power minus 4 volt. It reduces EMF 1.5 into 10 to the power minus 4 volt. And from plain to hilly areas, the temperature ranges from 30 to minus 10 degree centigrade. Means there is a 40 degree centigrade temperature difference. Hence, 1 degree centigrade, the EMF reduced 1.5 10 to the power 3, 10 to the power minus 4, and on the 40 degree centigrade temperature difference, we will get 6 into 10 to the power minus 3 volt EMF difference, which is very less from when we compare with the 12 volt battery. So this minor voltage fluctuation can be solved by 2 or 3 times self, and the battery will start to operate. But the major problem occurs when low temperature condense the electrolyte and the electrolyte will become solidify. Then the battery is unable to produce electric current, and we have to keep the battery at the room temperature, or we will just make many attempts of the self. Then, as you know, we know that this is exothermic reaction. So the condensed electrolyte get melted and the battery tends to start usual functions. So I hope that I have given a little bit informations about the battery. Please read the slide and try to rectify your problems. Thank you very much.